I wanted to call this video Guitar Making for Weekend Woodworkers and Other Guitar Enthusiasts with no woodworking experience who always had a dream of building their own guitar but never had a clue where to start. But that would have been a very long and confusing title. Anyway, now I hope you get the idea. Hi, I'm an amateur woodworker from Belgium, and I'm here to tell you everything I think I know about making a guitar at home. Before we start, you should know that I'm not a professional guitar maker. I don't sell guitars, I just make them for fun and always try to learn something along the way. I started woodworking as a hobbyist 3 years ago, and I only picked up on guitar making about a year ago. And in that time I've built 8 instruments, 6 of which are featured on my YouTube channel. I've been a Brian May fan for most of my life, and building a guitar on my own like he did with the Red Special has been a long time dream. When I was done with my first build, as I said, it was 15 months ago, I realized that in this day and age, with a bit of documentation, a bit of practice, the right tools and a lot of coffee, anyone should be able to make a half-decent guitar at home. In the end, you are probably not gonna sell that first guitar, and it might have some flaws here and there. But it's gonna be your first DIY guitar, one that you've built with your own hands, and that you can play after a long day at work, or simply watch with pride whenever you're feeling like an empty shell crushed by the burden of adulthood. If you think you're not good with your hands, then this will give you hope. 3 years ago, I didn't know how to use a chisel, or any of the tools I'm about to show you. But I was born in '86, which technically makes me a millennial. And do you know what millennials are good at? The answer is learning bizarre new skills out of boredom on their own just by watching YouTube videos in the comfort of their couch. And I've been doing a lot of that lately. Today, I'm gonna share my findings with you. In the first video of this 2-part series, I'm gonna talk about the tools needed for a guitar build, what they do, what you should buy, and what is optional. Then I'm also gonna talk about the hardware, wood options, the plans, timber dimensions, as well as more general consideration for a first-time build. By the end of this video, hopefully you will be ready for the second part, which will be a step-by-step guide through the build itself. The guitar we're gonna build today is a Telecaster copy. Like it or not, it's an iconic guitar, and one that I love. And I think it's the ideal guitar for a first project, and there's a host of reasons why. The main one being that it's the absolute simplest guitar design I can think of, but more on that later. This tutorial is based off of a guitar that I built using only hand tools, and one hand. But I make the vast majority of my guitars using both hand tools and power tools, and also both hands. If you're on a budget, or if you don't want to invest your money, time and space in expensive machines, I think the hand tool approach would be the best. In the description below, you will find a list with the names and brands of the exact tools that I use. If you start from nothing, the list may seem daunting at first, but with the exception of a couple of items, most of the tools are very affordable. And generally speaking, they are valuable woodworking tools. So in the end, even for a hobbyist, I think it's a good investment. Well, at least that's what I tell my family. Now let's kick off with the hand tools. My main saw is a double-edged Japanese pull saw. It allows me to crosscut and ripcut using the same saw. I highly recommend this type of saw, especially for beginners. It's very easy to use and it's a great general woodworking tool. But you can use any saw you want as long as it cuts through wood. In addition to the first saw, which can only cut straight, you will also need some kind of fret saw or coping saw to cut tight curves around the body and headstock. You will need a rasp to remove a lot of wood rapidly and with some control. I use a Shinto rasp. It's cheap, it's very efficient, and you can use one side for rough work and the other side for more detailed jobs. You will need at least one clamp, but I usually use 2, whatever I'm doing. The first one holds the piece down, and the second one keeps the piece from rotating around the first one. I hope it makes sense. In addition to regular clamps, you're gonna need a couple of long reach clamps to glue the body blank together. You will need at least a 6mm chisel, as it is exactly the width of the truss rod channel. I used a 15mm chisel for the rest of the build as an all-around chisel. By the way, those are cheap chisels, they cost 10 euros a piece, and they're just extremely sharp. You will need some kind of mallet to strike the chisel in. Anything will work as long as it's heavy enough. You will need a hand drill to drill holes for the strings to go through the body, but also to attach a lot of hardware to the guitar. If you want to make the guitar entirely by hand like I did, a hand drill is also very good at hogging out a lot of wood very fast. For this build, you will need some wood drill bits of various sizes and at least one Forstner bit. For the jackplate hole, you will need a 22mm bit. It can be a Forstner bit, a spade bit, or an auger bit. The spoke shave is optional. It does make shaping the neck look kinda cool on camera, but you can do it with a rasp. I put hand planes in the optional ones, because you don't strictly need one. But if you've seen my videos, then you know that I use hand planes all the time, even for things that could have been done with something else. I don't know, I just like hand planes. If you plan on doing any kind of woodworking in the future, do yourself a favor, and just get one. It's a great tool and it forces you to understand how wood grain works. I'd suggest the number 5 plane, also known as the jack plane, as an all-around plane. You will need a metal file for the fretwork, which includes making the fret ends flush with the fretboard, spot leveling, crowning, and rounding the fret ends. I also use metal files for very delicate works on woods. If you can only have one, get a straight one with the fine grain and a safe edge. You will need one of those to know precisely where to cut and drill. A marking knife is more precise than a pencil, and a box cutter just won't do, because you only want one bevel on the cutting edge, so that you can butt up the non-beveled side against the ruler. You will be more consistent and will save a lot of time by using either one of those marking gauges, but it's optional. If you want to get one, try to get the one with the wheel. It's great with oddly shaped pieces like a guitar. You'll need a thickness caliper, a square, a long metal ruler, and a tape measurer. I soldered my first harness with my wife's wood burning pen. It worked, but it was a terrible idea, because it was way too hot and there was no temperature control. Just buy a soldering station and some basic equipment. It doesn't cost much and it will make the harness a lot more reliable. You've probably seen me using the edge of painter's tape as a reference line. It gives me more contrast on very dark woods like walnut or wenge. By the way, I know it's pronounced wenge, even in French, but wenge sounds much more funky. Wenge! I also like to use painter's tape in combination with CA glue to hold my pieces down on the workbench, without having the clamps getting in the way of the plane or whatever I'm using at the moment. You can also use double-sided carpet tape. Aluminum or copper foil would be used to shield the cavities, but you can also use conductive painting. You'll need some 80, 120, and 240 grit sandpaper. For the fretwork, you're gonna need some 320 and 400 grit metal sandpaper. I use regular PVA glue for all of my builds, and I know it's a debatable choice. You could choose Titebond 2 or hide glue, but those aren't easily available where I live. You can use spray glue or a glue stick to attach the templates to the body, neck, and fretboard planks. I've mentioned my use of CA glue before, and it can also be used to glue the frets in place. Fret cutters are luthier's specialty tools, designed to cut fret ends flush with the fretboard. I've never had one, but instead I bought a cable cutter and filed off the upper part of the jaws, to mimic those of a fret cutter. It may not look sexy, but in the end it does the job, and costs the third of a price of a dedicated fret cutter. A radius sanding block is a block usually made out of wood. It has a concave bottom that matches the arc across the width of the fretboard, which is known as the radius. By sticking some sandpaper under it and sanding your blank for hours, you will eventually create that fretboard radius. This is by far the most tedious and least pleasant part of making a guitar by hand. I've wrapped my head around this one for a long time, and I couldn't figure any alternative. You will need to buy one. I did build one for myself, but this is out of the scope of this tutorial. Mine has a 9.5-inch radius, but the choice is up to you. The higher the number, the flatter the curve. Vintage Fenders are usually 9.5, Gibsons are usually 12, but you can find anything between 7 and 18 inches. It doesn't change anything construction-wise. You can also make the radius with the router and a radius jig, but again, that would take too long to explain. You will need some kind of fret leveling beam. You can buy them online, but I made my own by sanding a piece of square aluminum tubing on a flat tile, using metal sandpaper. It took me about an hour to make it perfectly flat. A miter box makes cutting the fret slots a lot easier because it ensures that your slots are square to the main axis of the fretboard. I made my first guitar without one and I could really tell a difference after I decided to build one. You don't need to build one from scratch like I did. Just go to the local big box store and get one there. Then, use your own saw to cut a second groove square to the fence so it matches the curve of your saw blade exactly. As you can see, mine has 3 grooves, one for each type of saw that I use. This one is optional, but it will certainly make your life easier. The curve of the saw is designed to make the fret tanks fit nicely inside the fret slots, without having to force them in and risking some damage on the fretboard. I put this one in the optionals because I've somehow managed to build 5 instruments without one, but that's only because by chance one of my Japanese saws has a curve that is very close to 54mm. You can buy them if you want, but those are very optional. I only started buying them one at a time when I slowly realized that guitar making was apparently becoming a thing in my life. And that was after about 5 guitars. Here are 3 power tools that can really make the process a lot faster and less frustrating for you. First one is the router, and it's the amateur guitar builder's best friend. You can use it to shape the entire body contour as well as the neck and headstock, to route out the pickup cavities, the control cavity, the neck pocket, the truss rod channel, the binding channel, and the fretboard radius. And that's about 80% of what making a guitar is, removing wood from where it's not supposed to be. Any router will do, as long as it can punch cut. In addition to the router, you're gonna have to get 3 different bits. You'll need a flush trim bit, a template routing bit, and a 6mm straight bit. The router also has some downsides. It's a dangerous tool, it's also very loud, it makes an unholy amount of dust, and the router bits always end up costing more than the router itself. And finally, no, a Dremel won't work because it's just not powerful enough. A bandsaw or a jigsaw can also speed up the process of cutting the body and neck contours. You don't need a big bandsaw like I do because making a guitar is not very demanding for a bandsaw. Finally, if you don't want to spend hours and hours making the body's side square to the top and bottom with a rasp, or if you want to remove the marks left by the bandsaw, the jigsaw, or the router, then get an oscillating spindle sander. This is the list of all the hardware and electronics that you're gonna have to get for this build. It's basically what you get when you buy a kit guitar, except here you get to choose exactly what you want. I will put links in the description to the exact items that I used. You will need fret wires, the size is up to you. But for a first build, I would recommend pre-bent and pre-cut frets. You will need a 43mm nut. I use pre-slotted nuts and I'm sure I would benefit from making my own nuts using bone material, but I haven't had the time to learn how to do that yet. You will need a double action truss rod. The one I used is 440mm and will be adjusted on the heel side of the neck with the hex key. You'll need a telly bridge, a telly pick guard, a control cavity steel plate, 6 string ferrules, 1 string tree, 2 knobs and a switch, a jack plate, an output jack socket, 2 strap buttons, push cloth wires, 2 pots, 1 capacitor, and a 3-way switch. And of course, you're gonna need a neck pickup and a bridge pickup. You can choose humbuckers or P90, but I chose single coils. Just make sure that the pick guard is appropriate, and don't worry about the pickup cavity size. Traditionally, the body of a telly is made out of ash or alder. The neck is usually maple, and the fretboard can be maple or rosewood. That being said, you can really pick any wood species you want, as long as it's hardwood, as opposed to softwood, even though the body of the Esquire prototype back in 1949 was made out of pine. Here's what you should consider when deciding which wood to buy. You've probably heard of tone woods. They are wood varieties that are said to have specific sonic properties, varying from one species to the other. For example, mahogany and rosewood are expected to sound warm, whereas maple, walnut, and wenge are said to sound much brighter. The weight of the wood should also be a concern, especially if you have a shoulder or back problem. In that case, try to use lighter species like basswood or alder. And generally speaking, try to avoid a neck dive by balancing the weight of the neck and the weight of the body. Not all woods are equal when it comes to sawing, chiseling, and planing. Some woods are very easy to work with, like walnut, ash, and maple. They have a medium density and are quite predictable woods, meaning that when I put my chisel in, I know exactly what's going to happen. I would suggest those woods for beginners, especially walnut. Other woods are very hard to work with, either because they're rock hard, like wenge, or because they have a grain pattern that is constantly changing, like sapele or ebony. Those woods aren't forgiving when you don't know exactly what you're doing. I get all my riffs on wood from a general wood store here in Brussels. They sell woods to companies making staircases, decking, roofs, and all those kinds of wooden things. In no way do they specialize in luthier woods. But lucky for me, the vast majority of the woods they sell happen to be suitable for instrument building. They range from domestic woods like ash, walnut, maple, to more exotic woods like mahogany, sapele, bubinga, or wenge. If you don't have such a wood store near you, everything's not lost. I'll try to find links to some web shops out there, and you should also check out eBay. For this project, I chose ash for the body because I wanted a very specific look with the finish on. I used mahogany for the neck because by chance I had a perfectly quarter-sawn piece left from my previous builds. And I used rosewood for the fretboard because I never tried it before, and when I built my shelf guitar, I didn't know if I'd use ebony or rosewood, so I bought both. Here's a quick list of the most commonly used species for each component of the guitar. And remember that this is electric guitars we're talking about. What I mean by that is when it comes to the sound, there are too many variables in play just to narrow it down to the wood choice. In the end, you get to choose whatever wood you want, depending on your tastes, budget, and experience with hardwood. Just Google Telecaster plan PDF and there's a ton of free plans out there. I'll leave a link in the description for the plans I used. The plans may seem overwhelming at first, but not all measurements mentioned in there are relevant to what we're trying to do here. As I mentioned previously, the Telecaster is a very simple guitar. And we're now going to take a look at the plan to illustrate what I meant by that. Somebody once said in my comment section that making a guitar is easy. It's just gluing woods together and then taking out everything that's not a guitar. Well, he or she wasn't wrong, especially for a tele build. The body is literally two pieces of wood glued together and then cut so the whole thing vaguely looks like a guitar. There's no complex carving on the top, nor in the back. There's no comfort cut, no belly cut, there's no complex routing to get the electronics in, there's no backplate, no mortise for a set neck, no neck to body transition, no neck angle. It's just a stupid block of wood with holes here and there. The neck is also very simple. You see, most guitars have their headstock angled towards the back to put some downward pressure on the strings at the nut. Such an angle is obtained by cutting the headstock angled that way or by making what is called a scarf joint. And while it is not very hard to do at all, it's still some more work and adds a tiny bit of complexity to your first build. Well, there's no such thing on a tele, as the headstock is simply on the plane that's parallel to the plane of the neck. You don't have to worry about any angle at all. Also, the bottom of the heel and the bottom of the headstock are perfectly aligned, which will also make your life easier when you're trying to clamp things. Now about the plan and what to do with it. You will need to print the 3 templates separately. We'll glue them on the body, neck, and fretboard blanks. Just print out any file you want because we only need the contour lines, the fret and nut positions, and the center lines. Those are the 3 elements that we're actually going to print out, because we're going to mark the rest of the measurement on the actual wood. I couldn't find a file with just a fretboard on, so just print the neck template twice, and then isolate the fretboard on the second time. Also, make sure that the printer is calibrated so it actually prints on a 1:1 scale. This is especially crucial for the fret positions if you want your guitar to play in tune. And also make sure that the center lines are perfectly straight on the 3 templates, because we're heavily gonna rely on them for the whole build. If you can do it, try to find a printer that handles A3 sheets. Because if you rotate the neck by 33 degrees, the fretboard will sit nicely inside one page, diagonally. No need for complex glue up, and you'll gain a lot of precision by doing so. We'll use the center line as a reference, and not the sides of the fretboard, so don't worry if you don't cut straight. If you have the tools to do the milling by yourself at home, that is a planer, a jointer, and a table saw, or if you know how to do it by hand, here are the dimensions. If you don't, then just download the cut list in the description box below and ask the good people from the lumberyard to dimension the wood for you. It's not worth investing in heavy machinery or learning how to do it by hand at this point. Just pay a little extra to the lumberyard and you'll have everything you'll need for your first guitar. A few very important things are worth mentioning here, if you don't want to run into troubles later. You can make the entire body with just one piece of wood, but larger and good quality pieces are pricier and they are harder to find too, compared to just cutting a board in two and gluing the pieces together. This last option also makes the body blank more stable, as it won't warp as easily as a one-piece body. Also, if you use 2 pieces, you can sort of book match them. The thicknesses have to be absolutely spot on and consistent across the board. That's 45 mm for the body blank, 19 mm for the neck blank, that is 3/4 inch or 9/15 of a potato, and 6.35 mm for the fretboard, or a 1/4 inch, or 2 bananas. I counted 100 mm of extra length on each board, because most of the planers, even professional ones, will leave some kind of snipe at both ends. Sometimes it's very subtle, but it's there. And you don't want your neck to wobble in the neck pocket, or your body to have a sudden dip next to your strat button. If you're confident that you won't have a snipe, then you can subtract those 100 mm. My snipes usually happen at 50 mm from the ends. If you have no idea what I'm talking about, then just trust me and get those 100 mm extra. Make sure that the milling process got rid of any twist, bow, or cup in your boards. You can check that by putting your boards flat on a workbench and then pressing on the 4 corners. If your board moves even the slightest, then it still has a defect and you need to address it. You need to have all the edges of the boards of your body blank jointed, which means that their edges are perfectly square to their faces. In fact, 2 would be enough. But if you have 4 of them, then you'll be able to play around with the wood figuring and try out every possible combination. As for the neck blank, you don't need to have any square edge, because we'll cut them anyway. It's easier to have one good edge on the fretboard blank because we're gonna use it as a reference for the miter box. About grain orientation. Quarter sawn is arguably the best choice because the wood will be more stable through seasonal changes. And that is especially true for neck and fretboard. But for a first build, I wouldn't care about that too much. If you can get your hands on quarter sawn or rift sawn, or if you don't have any idea of what I'm talking about, just buy anything pretty, hard, and well dried, and you'll be just fine. My body blank on this guitar is flat sawn, and I'm pretty okay with it. Oh, and try to avoid knots, or have them where you know they won't cause a problem. I will conclude this first part by sharing a few thoughts, so you have a better idea of what making a guitar at home will involve. I have a workshop at the back of my garage, but I haven't always had such a dedicated space. For a first-time build with a restricted number of tools, the only thing you're gonna need is some kind of workbench. And any kind of table will work as long as you can clamp things on it. But it also has to be stable enough, meaning that it won't fall apart when you strike your chisel in. Also, the whole thing will produce a lot of sawdust, so maybe don't do it in a kitchen or in your kid's bedroom. On average, it usually takes me about 4 to 6 weeks to finish a guitar project, but I'm pathologically slow. And since this is a hobby, and one that's supposed to be relaxing at that, I never feel any rush. So building a guitar at home is time consuming, but so is a 1000-piece puzzle, or stamp collecting, or bird watching. I'd rather make guitars though, because I'm not smart enough for puzzles, and I'm genuinely afraid of birds. The budget depends on where you decide to spend your money. But generally speaking, the thing that is going to make all the difference is the hardware and the electronics. Most of the time they will cost you more than all the tools combined. Just like with birdwatching, experience will help. But if you've never done any woodworking before, it's not a big deal. Building a guitar like a telly is not as hard as it seems. As I've said over and over, there's gonna be a lot of room for mistakes. I'll try to make a foolproof tutorial and will tell you when to be extra careful. Also, I'm probably going to upload a short video explaining you how to actually use the tools, as well as some tips and tricks for the main ones, that is the saw, the chisel, and the plane. I'll see you for the next video. It's gonna be the actual step-by-step tutorial to the build. I'm gonna take you to the workshop and I'm actually gonna show you what to do. And remember, I did it with one hand, so you can probably do it with 2. You don't have any excuse anymore.